Time travel in general is one of the most debated ideas across science fiction, and it does have a basis in science fact. We know at least that time isn't the static, unchanging force that scientists and philosophers once thought it was. Albert Einstein showed that time is actually relative and can be affected by something as simple as speed. Generally, the faster you go, the less time you experience relative to someone stationary. Technically, this makes traveling into the future totally feasible, but traveling into the past remains much harder. It's thought that to do so, you'd need to move faster than the speed of light, but that's probably impossible. Yes, some things seem to move faster than light, like universal expansion and quantum entanglement, but as we found in another recent video, that's possible because no new information is being transmitted. Nevertheless, the challenge remains a fundamental one in modern research. Could we ever break the unbreakable law of light speed? Perhaps the key is to start off with something smaller, carrying less information than a whole person does. Something like a simple message. It's an idea that's gained a lot of interest in recent years. Messaging speeds have gotten increasingly faster since humans first began communicating. In history, the sharing of information was initially limited to how fast someone could physically carry a message from A to B, on foot or on horseback or in mail trucks. But with the utilization of electricity, humans are now able to exchange information at the speed of light. First telegrams, then telephones, and today emails all work at light speed because whatever they carry is being transmitted as electromagnetic waves. But for time messaging, even light speed isn't fast enough. And it's a genuine, growing problem in the real world. Communicating with rovers on Mars, for example, can take between 5 to 20 minutes depending on our planet's positions, thanks to the rules of light speed. Such delays are impractical and potentially deadly in the future, so messages through time really are needed. The possibility of sending messages so fast that they actually travel back in time was something that Einstein considered in 1907. He and the theoretical physicist Arnold Sommerfeld came up with the idea of sending information back in time, or as they put it, telegraphing into the past. Later, the astrophysicist Gregory Benford would call the device that could make this hypothetically possible a tachyonic anti-telephone. It's called that because it would depend on an as-yet undiscovered potential particle called a tachyon, which can move faster than light and could therefore possibly be used to travel through time. Tachyons were first hypothesized in 1967 by the physicist Gerald Feinberg, who was working from Einstein's theory of special relativity. What makes them especially strange is that as energy is taken away from them, the speed of a tachyon actually increases, which can happen because they are anti-mass particles. Say a tachyonic anti-telephone was possible, however, it could quickly lead to some tricky paradoxes. Imagine, for example, two people communicating with each other across a vast distance in space. Person A who sends the initial message and person B who responds. Theoretically, if done with tachyons, person A could receive a reply to their question before they've even asked it, which would then mean that there'd be no need for a reply in the first place. This is sometimes known as Tolman's paradox, after the physicist Richard Chance Tolman. It shows that while the anti-telephone may have been devised to make things more efficient, it would in reality make things a whole lot more complicated. The wider problem with tachyons, though, is that they might not even exist, and even if they do, it might be impossible to control or measure them. Opinions differ, but for some, tachyons aren't impossible, because we know that our standard model of physics is incomplete, and there are some theories that try to improve it, including string theory, which contain tachyons in their model. It's still all very what-if maybe to modern minds, though. There is then another potential method for sending messages back in time that doesn't require a hypothetical concept, but rather a proven one: quantum mechanics. We know that there are many bizarre happenings that occur at the quantum level that make little sense compared to the macro world, but one of the most puzzling of all is quantum entanglement. Entanglement happens when two particles in some way become connected, as if there were an imaginary or invisible force linking the two through space-time. When this happens, the particles can seem to communicate with each other instantly, no matter how far apart they appear to be. It's what Einstein famously called, quote, spooky action at a distance, now widely known as quantum non-locality. An often cited example says that if two photons are unmeasured, then we know that they can be traveling either as a wave or a particle. But if one of those photons were then measured, then we can instantly know what form the other takes as well, even if it were an entire galaxy away. The photons are entangled. The information contained is to some degree sent through time. However, there are still problems afoot. Currently, researchers haven't quite figured out how to use this instantaneous phenomenon to send data, even though it seems as if the particles are able to share information. That's because so far we can't manipulate a particle at will. We can't make it act one way or another. It's just random. In fact, some theories are that the particles involved have already chosen their forms when they become entangled. So all we're ever really doing in experimenting with them is uncovering them. But still, if scientists could find a way to get a handle on it and send information via entanglement, then faster-than-light communication would technically be possible. The physicist John Cramer is a leading voice in the field, although it remains to be seen whether it really will yield time messaging. But finally, and briefly moving from the infinitely small to the infinitely massive, there's arguably one further possibility towards time messaging, using something else that stems from Einstein's initial work, an Einstein-Rosen bridge, or as it's more commonly known, a wormhole. It's said that by connecting a black hole to its theoretical opposite, a white hole, a bridge can be created through space-time, which would allow for anything passing through to again travel instantly from A to B. Research has shown that tiny amounts of information might feasibly be shared this way, although it could also be that the amount sent is hardly worth the energy in creating the bridge to send it. If they are possible, wormholes are spectacularly energetic and easy to collapse, which isn't a great combination. But might we one day still grow to use them kind of like we use a telephone today, by communicating along the bridge, sender and receiver on each side, so that the messages we're conveying genuinely move through time as well as space? Of all of the options, this one is perhaps the least likely of all, even if a souped-up smartphone with wormhole capability does sound pretty cool. What's your verdict? What is clear is that if time messaging were possible, then it could have some spectacular benefits. Long-distance space travel, but with instant communication. Vital data of any kind sent so that it arrives before you need it. An open window to the past and future, through which reality itself could be sent in an all-new direction. In the modern world, so much is riding on fast and reliable connection speeds. And really, in this alternate world, it would be much the same. Anything that could send a message further and further through time would be more and more sought after, until perhaps one day we'll be connecting with the very beginning and end of time all at once, because that's how time messaging might be possible.